Welcome to this Waste video tutorial. My goal is to show you how you can temporarily put one or more process tanks out of operation without incurring in nasty numerical issues due to zero flow rates. This is now possible with a new process model added to the Waste 2024 model library. What you see here is a fictitious process layout consisting of two identical trains, each comprising of a two-tank activated sludge system for nitrification and denitrification, followed by a clarifier. Tank A will assume it requires some maintenance and therefore will be put out of operation for a certain period of time, while train B will continue being operated regularly. The new model is called volume constant on-off, as opposed to the conventional volume constant. Two parameters have been added to the model. Is on, a boolean to indicate whether the tank is in operation or not, and qpump indicates the rate of the pump used to empty the tank when it is being put offline. This sample uses two top-level interface variables, one to switch off the tanks of the first train at a certain time, and then to switch them back on when maintenance has been completed. The second variable to divert the flow from the first train to the second when the first is put out of operation. The two variables are associated with an input file that we can plot here. You can see that between day 2 and day 3.5, the first train is switched off, while the second receives the entire flow. Now let's launch the dynamic simulation. Let's first take a look at the evolution of the tank volumes in the first train. You can see that once the inflow gets diverted to the second train at day 2, the first tank to empty is the anoxic tank, logically. This keeps the aerated tank fed for a short time, then the aerated tank 2 starts to empty. Conversely, at day 3.5, the anoxic tank starts to fill up again first, while the aerated tank remains empty for a little while. Thereafter, it too starts to fill up and normal operation resumes. We can also see that the sludge in the first train practically disappears. And once the train is put back in operation, it will take some time for the sludge to return to the previous steady state. In terms of process performance, operation in train A was good until obviously day 2, when maintenance begins. After day 3.5, when operation resumes, train A does not nitrify for quite some time. But eventually it goes back to the good performance it had before. On the other hand, train B operates quite well throughout the test period, but clearly suffers between day 2 and 3.5, when it receives twice the flow and load as usual. Now the combined effluent is obviously severely impacted by the out of operation of train A, and obviously follows the same slow recovery as train A, except slightly lower due to dilution. In summary, in this video, you have seen how an activated sludge tank can be temporarily put out of operation and then back into operation. Prior to release 2024, simulating this kind of discontinuous operation would have been extremely complex to set up and generally would have led to numerical issue. Hope you enjoyed the video. Thank you for watching.